The universe you can see has an edge. Not a wall, not a fog, but a hard mathematical boundary, roughly 46 billion light years away in every direction, past which no signal has ever reached you and none ever will. For most of human history, that boundary was simply where the map ran out. But in the last 2 decades, physicists have started treating it as something else, not the edge of knowledge, the edge of everything. And one theory near the end of this list suggests that boundary isn't just unreachable. It's unknowable in a way that no future telescope, no future civilization, no future anything can ever fix. But before we get there, we need to start with something that sounds almost peaceful. A sea of universes, blowing bubbles forever. All right, let's go. Number 10, the eternal sea of bubbles. In 1979, physicist Alan Guth at MIT proposed cosmic inflation to explain why the universe looks so smooth and flat. The theory worked almost too well. Within a few years, physicists, including Andrei Linde and Alexander Vilenkin, realized that if inflation is driven by a quantum field, it doesn't have to stop everywhere at once. In most models, inflation ends locally, producing a bubble like our universe, while continuing forever in the space around that bubble. New bubbles form inside the inflating background at random points, each one becoming its own separate universe, expanding forever, never touching the others under normal conditions. This is called eternal inflation. And among cosmologists who study the early universe, it's currently one of the leading pictures of how our reality began. What makes this particularly unsettling is what it implies about scale. If inflation is eternal, it hasn't just happened once. It's happening right now, in a space you cannot reach, producing new bubble universes at a rate that has no natural stopping point. Our own universe is just one bubble that finished inflating 13.8 billion years ago, drifting in a sea of other bubbles, most of which we will never detect, some of which may have finished with completely different values for gravity, for the strength of the electromagnetic force, for whether atoms are even possible. In October 2025, a team of physicists, including researchers from Shanghai Jiao Tong University, published a new method for searching the cosmic microwave background for the telltale scar of a bubble collision, a specific pattern in how the oldest light in the universe is distorted. No confirmed collision has been found, but the search itself tells you something. Serious physicists are actively looking for bruises left behind by other universes bumping into ours. The sea you're floating in might not be perfectly still. Number 9, the birth from actual nothing. In 1982, physicist Alexander Vilenkin published a paper that tried to answer the question eternal inflation leaves open. Where did the first bubble, the one that became our universe, come from? His answer was not a prior universe, not a quantum field, not empty space. He proposed that the universe emerged through quantum tunneling from a state with no space, no time, no matter, and no energy at all. Genuine nothing. The mathematics uses the same tunneling equations that describe a particle passing through an energy barrier it shouldn't classically be able to cross. Except here, the barrier separates true non-existence from a small, closed universe expanding under its own inflation. What makes this particularly disturbing is what it removes from the story. There is no before. There is no cause in the ordinary sense, no prior event that made this happen, because a cause requires time, and time is one of the things that didn't exist yet. Vilenkin's model doesn't require a creator, a prior collapse, or any initial condition at all. It just requires that quantum mechanics applies to the concept of nothing itself, and that nothing treated correctly is unstable. If he's right, existence isn't the default state that needed no explanation. Existence is the accident. The universe you're living in, every star, every choice you've ever made, arose because absolute nothingness apparently cannot hold still. Number 8, the collision that keeps happening. In 2001, physicists Justin Corey, Bert Overoot, Paul Steinhardt, and Neil Turok proposed an alternative to inflation entirely: ekpyrotic cosmology, named after an ancient Greek word for cosmic conflagration. In this model, our universe exists on a three-dimensional membrane, a brane, floating in a higher dimensional space. A second brane floats nearby. The Big Bang wasn't an explosion from a point. It was the moment these two branes collided. The energy of that collision converted into the matter and radiation that became everything you can see. A year later, Steinhardt and Turok extended this into a cyclic model, where the branes separate, are drawn back together by gravity over trillions of years, collide again, and reset the universe with a new Big Bang. What makes this particularly disturbing is what it means about company. In this framework, our universe was never alone. There's always been a second brane, close enough in the higher dimensional bulk to eventually collide with ours, indifferent to anything living on either side. The collision that created you was just the most recent one in a sequence that has already happened before, and if the model's correct, will happen again. Every galaxy, every civilization, every memory gets recycled into raw energy at the next impact, and something on the other brane, if anything is there at all, experiences the exact same reset from its own side, with no way to ever know we existed. Number 7, the universe as a projection. In 1993, physicist Gerard Haupt proposed something that still unsettles physicists who take it seriously. He suggested that the information describing everything inside a region of space could be fully encoded on the boundary of that region, using fewer dimensions than the space it describes. Leonard Susskind developed this into the holographic principle. And in 1997, physicist Juan Maldacena provided the first rigorous mathematical example, showing that a theory of gravity operating inside a specific kind of space is exactly equivalent to a theory without gravity living on that space's boundary. The interior and the boundary aren't two related things. They're the same thing, described twice. What makes this particularly disturbing is what it implies about depth. If the holographic principle applies to our universe the way it applies to Maldacena's model, then the three dimensions you're moving through right now, the sense that you have depth, that objects are behind other objects, that your body has an inside, may not be the fundamental description of reality at all. It may be a readout, a decoded projection of information actually stored on a distant boundary, the same way a hologram creates the illusion of a physical object from a flat piece of film. You would never be able to tell the difference from inside. Every physical law you rely on, gravity, the fact that this text carries meaning to you, would still work exactly the same. The only thing that changes is where the information actually lives, and it might not be anywhere near you at all. Number 6, the landscape of 10 to the 500. String theory requires that space have more dimensions than the 3 you experience, with the extra dimensions curled up into tiny, complex shapes. In the early 2000s, physicists including Shamet Katru and Leonard Susskind realized that these shapes can be folded in an almost incomprehensible number of distinct ways, each one producing a different set of physical laws when reduced down to our familiar 4 dimensions. The commonly cited estimate is 10 to the 500 possible configurations, a number so large that if every atom in the observable universe had generated a new configuration every second since the Big Bang, you would still be nowhere close to counting them all. Physicists call this the string landscape. What makes this particularly disturbing is what it means for the constants you take for granted. The strength of gravity, the mass of an electron, the number of spatial dimensions that unfold instead of staying curled. None of these are fixed by any deeper law in this picture. They're closer to a location, a specific address in an almost infinite space of possibilities. And our universe happens to sit at one address that permits atoms, chemistry, and you. In the vast majority of the landscape, none of that works. Stars don't form, matter doesn't hold together. Somewhere out there, if the landscape is real, there are 10 to the 500 minus 1 universes that look nothing like this. And the version you're living in isn't special because it was chosen. It's simply the only kind of address where anyone would ever exist to notice they were standing on it. Number 5, the black holes making more of us. In 1992, physicist Lee Smolin proposed cosmological natural selection. Every time a black hole forms, he argued, the collapse doesn't end in the destruction predicted by classical general relativity. Instead, quantum effects cause a bounce, and a new, causally disconnected universe is born on the other side, with physical constants slightly mutated from the parent universe, the way a child inherits traits from a parent with small variations. Universes whose constants happen to favor forming lots of black holes produce more offspring. Over immense timescales, this becomes a selection process, and the physics we observe should be close to whatever configuration is best at making black holes, since that configuration would dominate the population of universes that exist. What makes this particularly disturbing is the number involved. Our universe has already produced an estimated 40 quintillion black holes just from collapsing stars. If Smolin is right, every single one of them is a birth event. A new sealed-off universe expanding somewhere we will never observe, carrying a mutated copy of our own physical laws forward into its own unknown future. You are not just living inside a universe. If this theory holds, you are living inside a machine that is, at this moment, manufacturing an uncountable number of descendant realities behind the event horizon scattered throughout every galaxy, including the supermassive one at the center of our own. And none of those universes will ever know where they came from. Number 4, the wall you can never cross, even in principle. The observable universe has a boundary called the particle horizon, roughly 46 billion light years away, marking the furthest point from which light has had time to reach us since the Big Bang. But cosmologists distinguish this from a second, stranger boundary called the cosmic event horizon, currently about 16 billion light years away. This is the limit beyond which light emitted today will never reach us, no matter how much time passes. Because the accelerating expansion of space driven by dark energy is carrying those regions away faster than light could ever close the gap. What makes this particularly disturbing is that this isn't a limitation of technology. A civilization a billion years more advanced than ours, with telescopes of any conceivable size, faces the exact same wall. Some cosmologists, including physicist Lawrence Krauss, have pointed out that in roughly 100 billion years, the accelerating expansion will have carried every other galaxy beyond this horizon entirely, leaving any future observer looking out at what appears to be a single, static, empty universe, with no way of ever detecting the Big Bang, the cosmic microwave background, or the fact that billions of other galaxies ever existed. The information isn't hidden by distance in the way a mountain hides a valley. It is being permanently, physically removed from the set of things that can ever be known, and there is no instrument, present or future, capable of retrieving it. Whatever lies past that line, right now, today, is already gone in every way that matters. Number 3, the bruise in the sky. In 2004, astronomers analyzing data from the WMAP satellite identified an unusually cold, unusually large region in the cosmic microwave background in the constellation Eridanus, roughly 1.8 billion light years across. It became known as the CMB cold spot. The most conventional explanation is a supervoid, an enormous underdense region of the universe along that line of sight. And in 2015, a team using the dark energy survey confirmed the existence of exactly such a void, now called the Eridanus supervoid, sitting precisely where the cold spot appears. But follow-up analysis found a problem. The measured temperature drop in the cold spot is significantly larger than a void of that size should produce under standard cosmology, and multiple research groups since have found the supervoid explanation only accounts for a fraction of the anomaly. What makes this particularly disturbing is what remains on the table once the ordinary explanation falls short. Some cosmologists have proposed that the cold spot is a genuine statistical anomaly with no explanation yet, while a smaller number have pointed back to eternal inflation and suggested it could be exactly the kind of scar a collision with another bubble universe would leave behind. A region where the fabric of our own universe was measurably disturbed by contact with something from outside it. The debate remains unresolved, and the mainstream position favors an unusual but ordinary void. But it means that right now, If you know where to look in the southern sky, there is a real, measured, unexplained, cold patch in the oldest light in the universe, sitting exactly where a bruise from outside reality would be expected to sit if that reality is a bubble drifting among others. Number 2, the boundary that decides what's real. In quantum mechanics, whether a particle behaves as a wave or a definite object depends on whether it's being observed, and physicists have long debated what observed even means at a fundamental level. Applied to cosmology, this becomes what's called the measure problem. In an eternally inflating multiverse, every possible outcome happens somewhere infinitely many times. If every outcome occurs an infinite number of times, the ordinary tools of probability break down, because you can no longer meaningfully say one outcome is more likely than another when both happen infinitely often. Physicists, including Andrei Linde and Alexander Vilenkin, have spent decades trying to define a consistent way to measure probability across an infinite multiverse. And as of the most recent published analyses, no single method has been agreed upon that avoids paradoxes. What makes this particularly disturbing is what it means for the specialness of your own existence. In a strict, infinite multiverse, there isn't just another version of Earth somewhere. There are infinitely many, including versions where every possible variation of your life has already played out, and versions of you experiencing every possible variation of suffering and joy simultaneously, with no mathematical framework, yet able to say which of these copies is more real than the others, or whether that question even means anything. You were taught to think of your life as the one that's actually happening. The measure problem is the admission from the physicists building these models that they no longer know how to justify that assumption, even inside their own math. Number 1, the wall that will never answer. Every theory on this list describes something different. A sea of bubbles, a birth from nothing, a collision between branes, a hologram projected from a distant boundary, a landscape of 10 to the 500 addresses, black holes manufacturing new realities, a horizon that erases information permanently, a bruise that might be a scar. A multiverse where probability itself breaks down. But run through the details of every one of them, and a single thread connects all 9. Every single model requires something on the other side of a boundary you cannot cross. A boundary that isn't temporarily out of reach, the way the far side of an ocean was out of reach 500 years ago, waiting for someone to build a better ship. These are boundaries built into the mathematics itself. The cosmic event horizon isn't a fog that clears with a bigger telescope. The other brane in the ekpyrotic model isn't a location you could travel to if you lived long enough. The state of nothingness that preceded the tunneling event isn't a place, because place requires the space that hadn't been created yet. In 1996, cosmologist Max Tegmark and others began cataloging exactly this feature across competing multiverse theories, and found that nearly every serious model shares it. Not a distant answer, a structural absence of one. Physicists have spent over 40 years building increasingly rigorous mathematics to describe what lies outside the observable universe. And the strange achievement of all that work is not that it found the answer. It's that it proved, again and again, from completely independent directions, that the answer is built to stay out of reach. You're standing inside a reality with real working physics on this side of the line, generated by something on the other side of a boundary that the mathematics itself forbids from ever responding. Every theory of what lies beyond agrees on exactly one thing. It was never going to tell you. If you want to see more videos like this, click the video on screen now and make sure to subscribe.